In Milne Thompson method, we're looking at to find an analytic function when real part or imaginary part is given. Before that, please like, share and subscribe this particular channel and click on bell icon to get a new notification. Let us start now. Now we'll be going into Milne Thompson method. It's nothing but when imaginary part or real part is given, we can find the analytic function. It's nothing but Milne Thompson 0. Okay, if you consider a function f of z, which is equal to u of x comma y plus I v of x comma y. Okay, and this particular function is analytic. Okay, this is an analytic function. What is an analytic function? When it satisfies CR equation, right? It's nothing but Cauchy-Riemann theorem, right? Equation it has to satisfy. It says that du by dx should be equal to dv by dy. Another condition is nothing but du by dy should be equal to minus of dv by dx. And these particular conditions are satisfied, and we can say that it is an analytic function. Now, in Milne Thompson method, what we do, by using an imaginary part, we can find the analytic function, or by using a real part, we can find the analytic function. How do we do it? Let us understand this one. Okay. In a case 1, if you consider case 1, where we'll be having the nothing but a real part. What is real part? This is nothing but a real part of a function, and this is an imaginary part, right? So if you have a real part of a function like u of x comma y is given, okay, then how to find the value of f of z is nothing but, in step 1 what you do is nothing but, we know that f of z is equal to u plus iv, right? Now we'll be differentiating it with respect to x, then it becomes d by dx f of z is equal to nothing but du by dx plus I into dv by dx, right? In step 2, we'll be using the CR equation, right? We know the u value, but we don't know the value of an v. But we can know that dv by dx is nothing but du by dy, but minus comes here, right? So it becomes, just substitute it, d by dx f of z is equal to du by dx minus I into du by dy. So we can find that du by dx and du by dy, right? Is it, as we know the already given value is not the real value. Now coming to the step 3. Okay, in step 3 what we do, replace, okay, as x is equal to z and y is equal to 0, and we're doing the integration, the whole thing with respect to z, then we get nothing but f of z. Okay, now this is a method we can use to find the analytic function when real part is given, right? Now if an imaginary part is given, we consider this in a case 2. Okay, now the imaginary part is given, only imaginary part is given, v of x comma y is given. Okay, and we have to find the value of f of z, right? So step 1, we'll be using the same steps. Okay, step 1, f is equal to nothing but u plus iv, right? Then we'll be differentiating it with respect to x, then which is equal to du by dx plus I into dv by dx, right? Now coming to step 2. In step 2 what you do is nothing but using a CR equation. Okay, we know the value of dv by dx, but we don't know the value of du by dx, but we know that du by dx is equal to nothing but dv by dy. So we get as d by dx f of z is equal to dv by dy plus I into dv by dx, right? Now we're going to step 3. In step 3, what we do is nothing but replace x width is equal to z and y is equal to 0, and integrating the whole thing with respect to z. Then we get an f of z, right? Now this is a method to find the analytic function when imaginary part or real part is given. Milne Thompson method. I've just noted down the points. Okay. Now what we do is nothing but find the analytic function f of z. If real part and imaginary part is given, it's nothing but we know that f of z is nothing but u plus iv. Where u and v are nothing functions of x and y, right? And this is nothing but a real part, and this is an imaginary part. If any one of them is given, then we are defining the f of z. The first case, if real part is given, then we have to find the value of an f of z, right? So first step is nothing but when we're differentiating f of z with dx, then we get nothing but f dash of z is equal to du by dx plus I into dv by dx. Next step 2 would be using the Cauchy's Riemann equation, and we'll be replacing dv by dx to minus du by dy, as we don't know the value of an v. In the third step, we'll be replacing x by z and y is equal to 0 and integrate with respect to z. Then we get nothing but f of z in terms of z. It is nothing but an f of z, right? Now this is a real case. How to find the f of z? Now if the imaginary part is given, v is given, then we have to find the value of f of z, right? Same steps would be following. Step 1, find f dash of z, which is equal to du by dx plus I into dv by dx. Step 2, what you do? Nothing but replace the value of du by dx by dv by dy using a Cauchy-Riemann equation, right? And the third step would be replacing x by z and y is equal to 0 and integrating with respect to z. We get a f of z in terms of an z only, and it is nothing but f of z. Okay. Now coming to the questions. Okay, the question is analytic function w of z is defined as w is equal to u plus iv and z is equal to x plus iy. If real part of w is given as u is equal to y by x square plus y square, then w of z is. So they given that w of z is analytic, right? Again they are saying the real part of an wz is u, which is equal to y by x square plus y square. Now we have to find the value of w of z. So we'll be using the Milne Thompson method. In the step 1, we'll be differentiating w of z with respect to x. Then it becomes w of z is equal to du by dx plus I into dv by dx, right? Now coming to step 2, we'll be using the CR equation, right? And we'll be replacing dv by dx as we don't know value of v, right? So it becomes w of z is equal to du by dx minus I into du by dy. Now defining the differentiation of du by dx and du by dy. We know that u is equal to y by x square plus y square. Then du by dx, just differentiating with respect to x, it becomes minus 2xy by x square plus y square whole square. Now coming to du by dy, which is equal to, it becomes x square plus y square minus 2y square by x square plus y square whole square, which is equal to x square minus y square by x square plus y square whole square, right? So just solve it here. We get w dash of z is equal to, it is minus 2xy by x square plus y square whole square minus I into, this one is x square minus y square by x square minus plus y square whole square, right? Now we're going to step 3. In step 3, what we do is nothing but replace x is equal to z and y is equal to 0, and we'll be doing the integration to get the value of w of z. First, what are you doing? X is equal to z and y is equal to 0. And y is equal to 0, this one becomes 0, right? And you get only this one. So you get w dash of z is equal to minus I into z square by z power 4, right? So which is equal to minus I by z square, right? Now we'll be doing the integration. Integration of w dash of z dz is equal to integration of minus I by z square dz. So it becomes w of z is equal to nothing but just do it minus I into minus 1 by z, right? So which is equal to I by z. So we got the w of z is nothing but I by z. Now come into one more question. The question is, if imaginary part b is equal to x minus y by x square plus y square, the analytic function f of z is. So they are given that f of z is an analytic function, right? And they are given the imaginary part of it. That's nothing but b is equal to x minus y by x square plus y square. Now we have to find the value of f of z by using a Milne Thompson method. So coming to step 1. What you do? Find the value of f dash of z, which is equal to du by dx plus I into dv by dx. Now coming to step 2. In this one, we'll be using the CR equation, as we don't know the value of an u. So we'll be converting into v terms. Then it becomes f dash of z is equal to dv by dy plus I into dv by dx, right? So just differentiate it. Then we get f dash of z is equal to, now first we'll be differentiating this one with respect to y, and it becomes minus 1 into x square plus y square minus 2y into x minus y by x square plus y square whole square, right? We know that differentiation of u by v is equal to u dash of v minus v dash into v by v square, right? Same thing I have done it, plus I into, now with respect to x, then becomes x square plus y square into minus 2x into x minus y by x square plus y square whole square, right? We got this particular values. Now we're going with the step 3. It's nothing but we're replacing the values, right? So we'll be replacing x is equal to z and y is equal to 0, and we'll be doing the integration. If we keep y is equal to 0 here, y is 0, then this goes, right? So this becomes nothing but f dash of z is equal to minus z square by z power 4, right? Plus I into z square minus, this is 2z square by z power 4, which is equal to minus 1 by z square plus, this one becomes I into minus 1 by z square, right? So we got f dash of z is equal to minus 1 by z square into 1 plus I, right? Now we'll be doing the integration. So integration f dash of z dz, which is equal to, if you consider 1 plus I and minus is a constant term, then it becomes minus 1 plus I and integration of 1 by z square dz, right? So this one is equal to, it becomes minus of 1 plus I into This one is minus 1 by z. Minus minus goes. So which is equal to 1 plus I by z. That's nothing but f of z, right? Just integration of f dash of z. dz is f of z. So we got the f of z value, which is equal to what? 1 plus I by z.